Linear regression is the most common algorithm used in industry. We know that the supervised learning is divided into classification and regression, and linear regression algorithm comes in the regression category. Some of the popular examples of linear regression algorithms are financial portfolio prediction, salary forecasting, real estate predictions, and many more. In linear regression, we see that the relationship between the two continuous variables, one is the input variable, also known as the predictor, and the other one is the response variable, also known as the output variable. Input variables are independent variables, and the output variables, which are dependent on the input variables, are dependent variables. The aim of the linear regression is to find a linear equation which best fits the data. The best fit line is the one which gives the minimum prediction error of all the data points. The best line is also called the regression line. Here you can see that we'll try to fit many lines to data points, and the best fit line is chosen which gives the minimum distance from the data points to the regression line. The equation of the linear regression can be given as y equal to b0 plus b1 x. Here x is the independent variable, b0 is intercept, b1 is the coefficient of independent variable, which is also called the slope of the equation, and y is the dependent variable. Now let's explore what is b1. If b1 is greater than 0, we can say that the predictor and the target will have positive relation. That means with the increase in value of x, there will be increase in value of y. If b1 is less than 0, then the predictor and the target will have negative relationship. That means with the increase in x value, there will be decrease in y value. If b1 is 0, then the model will not have any influence of the predictor, and we won't be able to regularize the model. We'll discuss about regularization in our later video. Now let's see few of the assumptions that are made for linear regression. First of the assumption is that the linear relationship should be there between the feature and the target. Well, according to this assumption, there is a linear relationship between features and target, and the linear regression captures only this relationship. Now let's see this first scatter plot of the featured TV advertising and the sales. This tells us that the money invested on TV advertisement increases the sales. So this is a linear regression. In second scatter plot, you can see that the radio advertising does not have a complete linear relationship with the sales. Little or no multicollinearity between the features. Multicollinearity is a state of very high intercorrelation and interassociation among the independent variables. Here you can see that the pair plot and the heat map are used for identifying highly correlated features. With the pair plot, you can see there is no significant relationship between the features. With heat map, which gives the correlation coefficient of each features with respect to one another, which are in turn less than 0.4. Thus, from the heat map also we can say that these are not highly correlated. Now, why it is important to remove the highly correlated features? The regression coefficient is that which represents the mean change in the target of each unit change in a feature. We can say that when features are correlated, changes in one feature in turn shifts another feature. The stronger the correlation, the more difficult it is to change one feature without changing another. So this becomes difficult for the model to estimate the relationship between each feature and the target independently. Homoscedasticity describes a situation in which the error term is same across all values of the independent variable. Here you can see in this scatter plot the values are the residual value and the predicted value. The leftmost graph shows no definite pattern, that is the constant variance among the residual. The middle plot shows the specific pattern where the error increases and then decreases with the predicted values, violating the constant variance rule. And the rightmost graph also exhibits a specific pattern where the error decreases with the predicted values. At last, we have little or no autocorrelation in the residual. Autocorrelation occurs when the residual error are dependent on each other. The presence of correlation in error term drastically reduces the model's accuracy. This usually occurs in time series model where the next instant is dependent on the previous instant. Now let's see what is least square method. Least square method is statistical method used to find the equation of the best fit line. So we'll take an example and find the best fit line for it. We are taking the Domino's sales of pizza for the hour of the day. So with the table you can see that at 2 o'clock there were 4 pizza sold. At 3 there were 5. At 5 o'clock there were 7 pizzas sold, and so on. First we have to find the best b1 slope and b0 intercept. We have equation y equal to b0 plus b1 x. First we have to calculate the x square and product of x and y for each of the row. Then we'll take their sum. Also you can see that n, that is the number of the data values, we have 5. For calculating the slope we have formula, as you can see, that is n into the summation of x and y and the summation of x and summation of y by n into summation of x square minus summation of x whole to the power 2. From this formula we can calculate the slope, and then we'll calculate the intercept from the formula summation of y minus m into summation of x by n. We'll calculate b1 and b0 from this value and then we'll put it in our equation. Now we are taking all the data points and we are fitting it to our regression line. You can see there's one column that is the error. We'll discuss about this error in our later video.
Do like and subscribe.